Let's get started with the most basic parabolas or quadratic functions. We're going to graph when you only have f of x equals ax squared, no plus bx plus c. None of that, just this here. Here's my parent graph, and all the other graphs will be based on this graph right here. Some things I know is that the parabola is going to open up because the A is positive. It's going to open upward. If it were negative, it would open downward. Let's graph using a t-chart the first time, the parent graph. That's where we just place the -2 into the formula and then graph them. So -2 squared is 4. I have a point at -2, 4. So left 2 up, 1, 2, 3, 4. There's a point there. Then there is a point at -1 squared, which is 1, -1, 1. So left 1 up, 1. There's a point at 0 squared, which is 0, 0, 0. And then there is another point. 1 squared is 1. So 1, 1. And notice there's the symmetry there. And this must be the vertex. And then there's a point at 2 squared. 2 squared is 4. So there's a point at 2, 4. So right 2 up, 1, 2, 3, 4. Notice it's symmetric. This is the parent graph. And you don't have to make that each time, just until you get used to it. If it is y equals x squared or f of x equals x squared, you'll have a point at 0, 0, because that's the vertex. You'll have, you'll go right 1 and up 1 and left 1 and up 1 and put a point. And then you can go right 1 again and up 3 and go left again and up 3, and you'll get those basic points to make that parabola really, really quickly. If your A for your next one is not 1, you're going to need a t-chart to figure out what it is. And we studied earlier on the linear equations about vertical stretches and shrinks and such, and those also play a role in these, in the same role. All right, so let's take these. I've got 2 times -2 squared. -2 squared is 4. 2 times 4 is 8. So it's basically multiplying by 2. Well, multiplying these answers here by 2. So I have 2 times -1 squared. That's 2 times 1, which is 2. I have 2 times 0 squared, which is 0. 2 times 1 squared. 2 times 1 is 2. And 2 times 2 squared, which is 2 times 4, which is 8. So that is a point at -2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. I have a point at -1, 2, 1, 2. I have a point at 0, 0, same vertex. I have a point at 1, 2. See the symmetry? And a point at 2, 8. So 2, 8. This one here seems to be more narrow, and that's because of that A. It is more narrow than the parent graph. So this is my g of x, and this blue one here is my parent, which is my f of x. That's the parent function. They may ask you to compare them. They both open up. Notice that the vertex on both of them is at 0, 0. The axis of symmetry divides that parabola into 2 equal pieces, and that's where x equals 0. It is a vertical stretch, and that's because the A was 2, the red one was. There was a vertical stretch factor of 2. The domain for both of them is all real numbers. And then the range for both of them, that's the y's. It's going to be y is greater than or equal to 0.